Cool. So I'm going to be talking about a little project that we've been working on at the company I joined in November. It's called Sourced, and it's called gitbase. And I think it's a really cool little project, not only because of what it does. It provides a SQL interface to Git repositories. I'll show you how it works, but also because of the way it's actually built. Everything is open source, and we literally took pieces from like at least 12 different open source projects to make it work. So, you know, open source is pretty cool. So I'm Francesc Campoy, and I work at this company called Sourced. I'm VP of Developer Relations there, but we don't have marketing or sales or support, so I also do all of those things, because yay, startups. Yeah, I'm also on Twitter and on GitHub. I also do this YouTube channel, Just for Funk, which is on YouTube, and also started doing the same thing on Twitch. So thank you, Twitch. Yeah. It's pretty cool, but Just for Funk, oh, actually, one second, because that was actually taken, because people squat domains already. So I was not able to get the domain I wanted, so it's Just for Funk Live. There you go. So if you want to watch videos and stuff of me building things and insulting computers, that's where you find it. Here, I don't insult computers. Here, I do. Okay, so we're going to be talking about what is gitbase. So I'll show you a little bit what it actually does, and I'll do a quick demo. And then we'll talk about how it was built, all of the pieces behind it, the projects that power it. And then we have Q&A. So what is gitbase? Gitbase is, as I said, an open source project that is on GitHub, so you can go check it out. And it's also a SQL interface to Git repositories. What does that mean? This literally means that you can have a bunch of Git repositories and then do select star from commits. That's the idea. You can extract a lot of things from a Git repository, so commits and files and references and all of these things. But then at the same time, we go even deeper than that, and we also are able to recognize what languages we have, and we're able to parse them, and we're able to extract things from the things we've parsed. Which means that you can do things like, give me the most common function name in my code base with a single SQL statement, which is really cool, but actually kind of hard to do. So one of the ways we expose extra functionality that is not part of SQL is through custom functions. We have this custom function called language, which given a path and its content, so like whatever main.go and the content package main, it will able to tell you that this is Go. This seems like it should be something easy to do, but it is not, because we're really bad at naming things. So for instance, .m stands for MATLAB, but also apparently Objective-C, because why not? So I do not understand why Objective-C has .m. I don't know what the M stands in Objective-C, but there it is. So depending on what language you're writing, this should be able to find it directly. Also, if you want to use it directly without having gitbase on top of it, it is also a separate project called Henry. So this allows you to write things like this. And you're going to see that this is a really big request. You don't need to read the whole thing. The interesting thing is that actually what we're doing here is getting all the files and then actually checking for the language. So that is the interesting part. We're doing language of the entry name, so the name of the file, and also the blob content. So that is the interesting part. Why do we do the rest? Because Git is actually a tree of trees of trees of trees. So you cannot just say, give me all of the files, or you'll get way more files than you expected. What you need to do is actually going to expand the repository, go to head, then get the commit, the last commit related to that branch, and then go to the first tree entry, and then iterate over all of them. So it's actually kind of complicated. We did not invent Git, and we didn't invent SQL, so we just have this. We're going to be improving this by providing functions eventually, soon. So basically what we're going to be able to say is, give me the files on master. And that will be just a single function rather than a natural join of 5 different things, which was fun to write, but not easy. So yeah, but the interesting thing is this part. So we can get the language and then count the numbers of lines of code. There's another project, it's called Bubblefish. And I have stickers later if you want to, this cute Bubblefish sticker. The whole idea of this project is that it's able to parse any language. Now, any, for some definition of any, being like 12 right now, maybe a little bit more. But the whole idea is that this is actually very easy to extend because it uses Docker. So every new parser is a Docker container, a Docker image. So you can write the parser in the language that you're parsing, which makes it much easier. If I tell you to write a parser for Go in Go, it is much easier than if I tell you to write a parser of Go in Java, right? Like the amount of work they're gonna need to do is quite different. So that's why we did this. And this is a different server. This is the Babelfish BBLFSHD. That is the Babelfish daemon that gitbase uses. So there's actually a gRPC API, so that's why our gitbase server is going to be using this server. There's a separate one. So now we have two servers in order to run this. The cool thing about this is that you can do things like this and say, I'm going to get the language of this file. So that language, file, path, blob content, that's going to return what language you're working on. And then use that to pass it to UAST function to say, actually parse this. And then on top of that, you have the filters. And for filters, since we work with trees, what we can do is use XPath. I personally hate XPath. I think it's a very complicated language. So we are considering changing it for CSS selectors because they do the same thing and people understand them. But we're still not there. So in this case, for instance, this will, for all of the files that we're working on, which are files that are Go in head, we are able to extract the things that are function declarations. So that role function and role declaration that extracts all of the nodes in the tree that do that, and then with array length, we're able to count them. So if you execute this, it will find all of the Go programs in your code base and count how many functions they declare. So this is just a couple of examples of the things you can do. So problems with gitbase. We just started, and there's 2 pieces. And there's actually more pieces. There's a bunch of different little services and things that you need to set up in order for gitbase to work correctly. I had the idea of using Docker to manage Docker and then put some Go on top. So the main idea of this is rather than having people install everything, if you tell them to install Docker, then you can use a Go program that will use the Docker API to install the things, right? It's kind of like if you've ever used Docker Compose, but Docker Compose is a limited language. What I'm doing is writing in Go, which allows me to do way more interesting things. And that is what we call the source engine, which is also open source. It's Apache 2, and everything below is also Apache 2, so feel free to go play with it. And we announced it this morning, yay. So yeah, I'm jet lagged and didn't sleep much anyway. So fun, and we released it this morning. And so why are we even doing this? Right, like gitbase sounds cool, but why are we doing it? Well, actually, it's not because we care about SQL itself, but because we care about machine learning. And in order to machine learning, you need a lot of data. So we are trying to do ML on code. That's the left part, right part for you. And machine learning on source code, basically what we're trying to do is understand many things from source code to build better tools. So one of the things we announced here too was also Lookout Alpha, which is assisted code review. It's an intelligent bot that allows you to do your code reviews faster. It uses machine learning for this. To do machine learning, something you need is lots of data, lots of it. And you need to know exactly what pieces of data you want to do. Now, extracting that data is really hard. So that is why we created gitbase. We created SQL. No, we didn't create SQL. The cool thing about this is that we created gitbase because we needed it for our project on ML on code, but then it turned out that this is actually useful for people. There's many large companies that are using it. One of them, you may have heard about it, is GitHub. So GitHub is using this, apparently, because I asked this question during my talk at GopherCon, how many lines of code are there on GitHub? And they do not know, which kind of blew my mind. It's actually a hard question to answer. So if you want to learn more about machine learning on Go, on source code. I gave this talk at GopherCon, which is already online, so just search that and you'll find it, and it's adorable. The talk is not adorable though. So, okay, so quick demo. So I'm gonna be using the sourced engine, which is simply do sourced. When you run this, you'll see this like a Cobra application ready to go, fully open source and everything. So I can do sourced SQL and just run this. And now I'm on a SQL server. Oh, that was a bad idea, actually. 1 second. I'm gonna kill all the things. I'm gonna go to somewhere where it makes sense. Let's go to all of my repos. So I can do sourced SQL, select star from repositories. And now what's going to happen is that this is actually going to realize that gitbase is not running. So it will download the gitbase image and then download all of the things that it needs, bubblefish and all of these things, in order to make things work, right? So if you download this binary and you have Docker, that's it. Everything else already works, right? So it's kind of like the idea of doing plugins. How many of you have used gCloud, the Google Cloud thing? That uses plugins through the power of Python, and it's a mess. It is incredibly hard to. No, it actually works really well, but the engineering behind it is super complicated because of the limitations. By using Docker, we're removing all of those limitations. So yeah, so those are all the things. Bunch of different things that I have. You can also do select star from repositories, not from refs, and you will see that there's already a bunch of them because every single repository might have a bunch of different references. Every tag, every branch, every single one of those things is a different reference. So that's why if you do not limit those, you really quick you get a combinatorial explosion. Yeah, that's the word. So combinatorial explosion, which is why we need to limit saying actually just head. All the things that you can do is show tables. These are the tables. This is how we represent Git in SQL. So you have references and files and commits and blobs, but also a bunch of different things to put all of those together because it's not one-to-one, it's many-to-many. A blob can be part of many different things, which makes things complicated. Also, some people do not like to write this, to write SQL directly on the command like this. So you can do sourced web SQL. And that will download and open a playground. And this is the playground. Now, I'm not going to run it here because I was working on it and I broke it. So instead, I'm going to be running it on, we have a playground on staging that it's public, so you can go play with it. So you can, for instance, list all of the, let me make it a little bit bigger, repositories, run it here. And you see, there's not many of them. There's only 1, 2, 3, 4, 5 repositories. But then you can do pretty interesting things. There's a couple sample queries that I'm going to use. So for instance, this one is going to get all of the files called main.go on head for every single repository. And also it's going to show the language, which, you know, if they're called main.go, the probability of being Go is pretty high. And then also it's going to parse them. So if we run this, it's going to take a little bit because it actually needs to do a bunch of things because it's actually parsing every single Go file that it's going to find, taking into account that all of the repos we had in there were Go. So this should take around 15 seconds, which means that, oh, there you go, 16.76. Okay, cool. So now a couple things that we are able to do because this is Git-based, not only SQL, is we're able to do things like, oh, we know that you're printing code, so we're able to show it here. Soon, it will detect it automatically and show Go. So you can see function main, you can see what it imports, and this is the code. But also we have the parse thing, the universal abstract syntax tree. And universal is universal in the fact that is as universal as JSON is universal or XML. It's not about the content, it's about the format, right? So we just have a common format, which is a Proco buffer, and then you can parse things and extract things that you care about. So this, for instance, children. So that's our package with not children. And then next one should be an identifier with main. So those two together are package main, right? So you can extract these things from there using UST query, which is the XPath thing that I showed you, which I have no idea how to write, so I'm not even going to try. But that should work. Let me see if there's, this should count top languages by repository count. And when you run this, you get this beautiful robot, and it tells you the languages by in how many repositories you can find it, right? So you can imagine that if you have this in a really large organization, you're going to be able to understand things like, well, how much code are we writing, but also over time, is the amount of code we're writing accelerating or decreasing or things like this. It's actually something that if you're a director of engineering and things like this, you need to answer those questions. And it's not necessarily easy to answer. So with this, we think it should be easier. Also, if you go with something really crazy, it will crash. So I'm actually going to make it crash just because I like the bot. That is the bot when you run. Yeah, I think it's cute. Okay. So that is gitbase. Okay, so now let's talk about how was it built. So the first piece we used is called Vitesse. How many of you have heard about Vitesse? Okay, Vitesse is a project that when I joined the Go team, we kept on talking about it all the time because it was the project written in Go, okay? There was no other open source project written in Go. Then we got Docker and Kubernetes, and nobody talks about Vitesse anymore. But Vitesse is a piece of, it's a layer of Go that YouTube uses to make MySQL scale. Basically, they have a lot of different concerns, one of them being sharding, as Blake was mentioning. And if you have a really large set of MySQL instances trying to keep each other up to date, it will not work very well, unfortunately. So if you want to do good sharding, Vitesse can help you with that. Now, the cool thing about Vitesse is that one, is open source, and two, is very well written. So we're able to just get one piece, which is the SQL parsing. So we're able to just get that SQL parsing and put it in a different package that we call Go MySQL Server. There's a great talk by Sugu. Sugu is a great guy that left Google to join YouTube 2 days before Google acquired YouTube, and then he came back. Yeah. He was lucky. I think he made, I don't know if you make money in that case, to be honest, but anyway. So we make that available with Go MySQL Server. And this package, to be honest, I didn't know much about it. And it's super useful. It is a SQL server that you can extend to do whatever you want to do, right? So when you think about the SQL server, I tend to think about a SQL server being a database, but that's not what it is. A SQL server is something that exposes a SQL interface. The same way you have REST interface or GraphQL, SQL is just one more interface, right? So what is behind it can be anything. So I wrote this piece of code, which didn't work, so I'm going to show it here. CSVQL. And it's a pretty simple thing, which I wrote 3 hours ago. And it uses that package that I showed in a very easy way. So actually what I care about is this one here. So this is the code. It just gets, it creates a new database SQL and it adds it to a default server. The interesting part is here. This new database, this is actually a database interface, which is how we can extend things. And that database interface has things to say, what are the tables, what are the columns inside of a table, what's the schema, and then what are the rows inside of those tables, right? So if you want to look at the code, it's everything in here. So you have this new database that returns a SQL database, that is the interface. and then new table that returns a SQL table. And total is 133 lines of code, Go code. You can go read it later. The interesting thing about this is that if you go to gitbase, go save. No, actually I moved it. CSVQL test data. So I have these two files where I have cities and people. And just by having this, now I can run CSVQL, and I'm serving this now a server. This is a SQL server. So I can connect to it. We're running MySQL. And so now I'm using the MySQL binary, which is something that comes with, well, I actually don't know if it comes with Mac or I'm installed with Brew, but it's a binary that doesn't know anything about my program. It's just gitbase. And I can do things like show tables. And that is showing all the files that I have. Describe table cities. I can show the fields that I have. I've said that all of them are fields, are text, because unfortunately there's no schema in what is the language? CSV, thank you. I was thinking YAML now. I don't know why. Kubernetes probably. And then you can do things like select star from, okay, I don't know what happened there. Select star from people. So you can see all the people, and you can do things. People were last equals Campoy, and you will see me and my sister. I did not write anything about parsing SQL, about comparing fields, all of that part. That is the SQL server, the SQL Go MySQL server. So if you have any ideas on where to use this, I think like super cool package that might be interesting to many. I was thinking that it'd be an interesting way of exposing everything, all the services and services and pods and things that you have in Kubernetes. You could have a database for it, and then you put like a front end on top and whatever, and you can do many fancy things if you feel like it. Okay. So now the problem is this is really cool, but it's also incredibly slow, like really slow. So how do we make it go a little bit faster? Please come in the middle. Bye. Okay, so how do we make this go faster? There's a bunch of different things that we have to do. Of course, like pprof and things like this to make sure that our Go code is faster, but that's not enough. One of the things is if you want SQL to go fast, you need indexes. And those indexes are not part of Vitess. So we use this other project, Pilosa, which is fully written in Go. And you can use it either as a server, a standalone server, or even as a little library that you can embed into your Go code. So it's super cool. It's completely open source. And I brought stickers from them too, because I've met them at GopherCon, and they were very happy that finally someone was using their software. So it is very, very cool piece of software. Also, we cache as many things as possible. And in order to cache, we didn't want to reinvent the wheel. So we are using something written by HashiCorp. And HashiCorp copied it from, well, got inspired by Group Cache, which is a distributed memcache, if I'm not mistaken, or something like that. Let's call it distributed memcache. That is written by mostly Brad Fitzpatrick at Google. And then finally, I don't know how many of you have read this paper by Russ Cox about regular expressions and how actually regular expressions are very complicated. And there's two ways of parsing regular expressions. One of them is linear, which is the one that Go uses. It's the one on the left, Thomson NFA. The other one is the one that basically everybody else uses, which is exponential, eventually. The problem is that for most of the time, the linear one is actually slower than the exponential one, because that's how maths work. So the thing is that by default, we use this one, the one from the standard library. But if you want to, since most of the time, especially if you are aware of which regular expressions you'll be running, because you're the one writing them, you might want to use the one in red. So there's a C++ library called Onigorama that does this very well, and there's a Go binding for it called Rubex. So we use that optionally with gitbase too. And that actually makes things much faster. Because the problem is that as soon as you have one regular expression, you're going to be running that regular expression over millions of rows. So that actually counts a lot. So to finish, we want you. Everything is open source. So have fun with it, play with it, break it, file issues, send PRs. Like PRs are cool. So everything is under github.com/src-d. I will post the slides online so you can look at them and play with all the links that I had. And also, we are definitely hiring. So, so if you're interested, we hired either here in San Francisco or remotely around the world. We have a very cool office in Madrid, which has really good food, if you're interested. And that's it. Thank you very much. And I think we have some time for questions. So if there's any questions, there was a mic that you might want to use. Any questions? Yeah, sure. I was going to throw it, but
Hello. Okay, cool. I guess my question is actually about the tool that you're using with on top of gitbase.
Yeah.
The alpha that you announced for the code review thing, is that available for integrating into like a CI pipeline or anything like that?
So it is not part of CI. It's more part of once you create a PR, you can run it kind of like CI, but it will add comments to the code itself. Right now we are using it. There's only it only works for JavaScript, which we will be fixing very soon, because our focus first is linter for formatting. So we have GoFont, so it makes it kind of useless for us. But for JavaScript people, it actually is very useful. And the problem with formatting in JavaScript is that there's no one single way of doing it, which means that you end up having a lot of different configurations for every single project. So what we're doing is we are learning the formatting from a repository given the source code itself. So we extract the formatting rules and then we apply them to the pull requests. And that's something that works now. So if you're interested in that, check the, so there was here, medium.com/sourcetech. It's the latest thing we've published this morning. And you should be able to see it there. There's links on how to join it. It is alpha, so, you know, lower your expectations. There's a possibility of it working. That's basically alpha, so yeah. Yeah, there's a question down there.
Does it use machine learning to do the formatting?
Oh, does it use machine learning to do the formatting? Yeah, so it doesn't use machine learning to apply the formatting. It uses machine learning to learn the rules that it should apply. And it's the main point of using machine learning to learn the rules rather than applying it directly is that then we can explain when something is wrong. Rather than saying, no, this is wrong, we can say, this is wrong because we learned the rule that after every single, I don't know, like when you start a comment, you have 2 spaces, and here you have 3. So that's a rule violation for this specific rule that we learn somehow, because explaining machine learning is kind of hard. So, yeah.
I know you guys just started, and it sounds really exciting and everything.
Yeah.
How does this scale?
How does it scale?
Like a prime example I can think of is somebody checking in a binary that's 2 gig. Like is it something that people do on the regular without thinking about it? Like,
everything. Now, so, I mean, luckily there's limitations on GitHub already. And for now, we only run on GitHub. So if you try to upload 2 gigs of binary, I'm almost sure GitHub will say no. Hopefully, I'm not completely sure, but I hope it says no. Most of the time, what we do is, so there's 2 things of scaling. One is on the size of the file, which unfortunately, you cannot really shard, right? Like you cannot shard the file and parse it just by fractions. It's very hard to do or impossible. So for that, unfortunately, it might take longer. Now, Bubblefish does scale. it does automatic scaling, so we'll start more containers if you are sending a lot of traffic, so that should fix it. The other side is scaling regarding the number of files and the number of repositories, which is the normal thing that people have, right? Mm-hmm. And in that case, what we are doing is sharding. So repositories are independent from each other, which is awesome because it makes it much easier for us to divide the work. Then we need to unite, put everything together. So if you're saying max, right, like give me the repositories with the highest number of Go functions or something like that, you need to put those together, which is not obvious. In order to do that, we're actually adding a layer of Hadoop on top of the engine. So what we want to do is make the engine a source, SQL source that Hadoop can use, and then just hope for the best and hope that Hadoop will work. But we're starting now. We're starting with that like literally right now. So
cool, that's great.
Yeah, pretty exciting if it works. Any other questions? Okay, so in that case, I'm just gonna use the same slide. So thank you for coming. Now I am the MC, by the way. So thank you for coming. If you have any more questions, I think that we have a little bit more time, so people are gonna be downstairs, I guess? Okay, cool. So we're not being kicked out just yet. Cool. So if you have more questions, there's also more pizza, I'm sure, because there was a lot of pizza. So I'm sure there's more pizza. So if you wanna go enjoy it, let's go downstairs. Thank you.